This culminating experience and professional development presentation is about the use of virtual reality in mathematics education. Here is a roadmap of what we'll be covering today. We'll start by defining exactly what virtual reality is in the context of mathematics. Next, we will try to answer why should we teach math with VR, and then see some of it in action with some of the leading platforms. Then, the VR advantages for math education, followed by the challenges we still face. Then we end with what the future looks like regarding VR and math education, followed by our conclusion and references. Now, let's start with the fundamental question. What exactly is virtual reality in the context of mathematics? At its core, virtual reality, or VR, is a technology that completely immerses you in a computer generated, simulated three-dimensional environment. When you put on a VR headset, it replaces your physical surroundings entirely, transporting you into a digital world. But for us, in the realm of mathematics education, this means something truly profound. It means literally stepping into the numbers, the shapes, and the functions. Imagine being able to walk inside a geometric solid or physically manipulate an algebraic equation. VR transforms those often abstract ideas, which are usually confined to a flat textbook or whiteboard, into tangible, interactive experiences. The key takeaway here is that VR fundamentally shifts math learning from being a passive observation, just looking at symbols on a page, to an active, embodied participation, making even the most complex concepts concrete and intuitive. So, why should we embrace virtual reality in our math classrooms? What are the key benefits that make this technology so compelling for teaching a subject like mathematics? Firstly, it offers enhanced visualizations. Think about a complex concept like a multivariable calculus, abstract functions, or intricate geometric structures. On a 2D page, they can be incredibly difficult to grasp. VR allows students to literally see and comprehend these ideas in a dynamic 3D space, making this abstract tangible. Secondly, VR enables truly interactive exploration. Instead of just looking at examples, students can physically manipulate virtual objects, change variables in equations, and experiment with data. This fosters active discovery and hands on approach to problem solving that static textbooks simply can't replicate. Thirdly, it forges crucial real world connections. VR can transport students into scenarios where math is inherently applied, whether it's designing a virtual bridge, calculating trajectories in a simulated environment, or managing a virtual budget. This makes math relevant and deeply engaging, answering that age old question, when will I ever use this? And finally, the immersion inherently leads to increased engagement and retention. Learning in VR is a multisensory experience that combats the boredom often associated with traditional math instruction. When students are deeply engaged, they retain information far more effectively, leading to a deeper understanding and improved memory. According to Fortune Business Insights, the VR education market is exploding and is expected to earn over $65 billion a year by 2032. Now, let's look at how VR brings specific math topics to life. There are This is where the true power of immersion becomes clear. For geometry and spatial reasoning, VR is revolutionary. Students can literally walk inside shapes, manipulate them in 3D space, and intuitively grasp concepts like volume, surface area, and angles, far beyond what any 2D drawing can offer. In algebra and functions, VR makes abstract relationships visible and interactive. Imagine changing variables in an equation like y equals mx plus b and instantly seeing the line transform into a 3D graph. This solidifies understanding of cause and effect. For higher math like calculus and data visualizations, VR allows exploration for complex derivatives and integrals in dynamic 3D environments. Even large data sets can become navigable, immersive landscapes, revealing patterns that otherwise are hidden. And finally, for problem solving, VR places students in realistic virtual scenarios where they must apply mathematical thinking and solve challenges, fostering critical thinking and hands on experimentation. Now let's highlight some of the leading platforms that are actively bringing VR into math classrooms today. First, Prisms VR. It's a pioneering platform focused on spatial learning. They make abstract algebra and geometry tactile and experimental. For instance, students can physically interact with exponential growth models, seeing how variables literally impact real world scenarios, which helps bridge the gap between abstract equations and tangible phenomena. Next, we have Class VR, which offers a wide array of curriculum aligned math content for various age groups. They provide engaging modules covering concepts from basic 3D shapes and virtual money mazes for financial literacy to interactive scenarios for understanding ratios. And finally, a powerful tool like GeoGebra is also available in a VR platform. Many teachers are familiar with GeoGebra from their basic 2D components that we use on the computer. However, they do offer VR programs and is a good one to look into if you're new. Here, they empower students and teachers to create, manipulate, and interact with complex 3D mathematical objects and functions. These allow students to virtually walk inside their geometric constructions and explore mathematical relationships from all angles. These platforms are just a few examples demonstrating the power and the growing potential for VR, making math more accessible and engaging to students. Now, for a deeper look at the distinct advantages VR offers in math education. Firstly, it's about concretizing abstract concepts. VR uniquely transforms abstract mathematical ideas into tangible, interactive experiences that students can physically engage with. This makes complex concepts far more accessible than traditional methods. This allows for immediate visual feedback. Students see the instant visual consequences of their mathematical choices and manipulations. This rapid feedback loop accelerates understanding and promotes self correction on the spot. VR also can help excel by boosting motivation and perseverance. Its engaging nature makes traditionally challenging math topics less intimidating, fostering a crucial, let me try that again mindset. This encourages students to push through difficulties. It also lends itself to force a safe space experimentation. Students can freely test mathematical ideas and make mistakes in a risk free environment, which is vital for building true understanding and problem solving skills without fear. This effectiveness is supported, and some research even shows that VR learners are 275% more confident in applying their skills learned after training versus regular or traditional mathematics learning. While VR offers incredible potential, it's also important to acknowledge there are disadvantages and challenges that we still face in its implementation for math education. Firstly, high costs are a significant barrier. Headsets alone are a notable investment, and then creating or licensing quality specific math content adds substantial expense, often exceeding $100,000 for complex applications. Then there are the technical and logistical hurdles. Managing the devices, ensuring strong Wi Fi, and handling ongoing maintenance can be complex for schools. Crucially, teacher training and integration is vital. Educators need specific pedagogical training to effectively weave VR into math lessons. Otherwise, its risk is becoming just a novelty rather than a core teaching tool is very real. Health concerns can also be a problem for students with disabilities. Some students with epilepsy or other students may be susceptible to motion sickness or discomfort, so careful session management is also going to be necessary. We also face challenges with curriculum alignment and content depth. Ensuring VR content perfectly matches every specific math standard is an ongoing development at task. And finally, equity of access is paramount. We must ensure that all students, regardless of their school's resources, have fair access to technology and the necessary learning management system supports. Addressing these challenges is key to virtual reality's successful integration into math education. Now let's look ahead at the exciting future of VR in math education. These advancements promise to further revolutionize how we learn. Imagine AI powered math tutors directly in VR, providing adaptive, personalized guidance, identifying misconceptions, and giving real time feedback, like a dedicated virtual coach or tutor. We'll also see a collaborative global math hubs, multi user VR space where students from anywhere can team up to solve complex math problems together, working on shared virtual whiteboards. As technology advances, we can expect seamless integration. This means teachers will assign VR math modules directly through platforms like our learning management systems, and student progress within the immersive environment will be automatically tracked for assessment. Beyond pure VR, mixed reality, or MR, for real world math will be significant. Picture overlaying dynamic math concepts into real world objects, like seeing the stress calculations on a bridge or trajectory equations for a soccer ball in your own environment. And finally, advanced haptics will emerge, allowing students to feel mathematical properties, adding a crucial sensory dimension and understanding concepts like resistance and precise alignment. These aren't just concepts, they are the next wave of innovation, promising even more intuitive and powerful ways to learn mathematics. As we wrap up, I want to reiterate that virtual reality is not merely a technological novelty. It's a profound pedagogical tool poised to fundamentally transform mathematics education. Its impact is undeniable. By allowing students to literally step inside and manipulate abstract concepts, by fostering deep engagement through immersive experiences, and by providing unparalleled opportunities for interactive exploration, VR empowers students to move beyond rote memorization and truly understand and ultimately master mathematics. It bridges that often challenging gap between abstract theory and intuitive understanding. My call to action is for all of us to embrace this potential, explore the VR math tools available, advocate for their integration to learning environments, and prepare our students not just for today's math problems, but for the complex and analytical challenges of tomorrow's world. Thank you.